So our next topic is rainfall. Rainfall or precipitation is always measured by an instrument called rain gauge. So the rain gauge is the instrument by which we can easily measure the intensity of rainfall. So rainfall is usually expressed in centimeters or millimeters. We can express the rainfall as centimeter or millimeters. If 50 millimeters rainfall is recorded in a particular day in a particular town, it means that if the rainfall is the town were allowed to collect over a plain surface, the level of rainwater over that surface would be 50 millimeter high. Okay, so this is the amount of rainfall. Generally, the rain falling over an area does not get collected. It runs off or seeps into a soil or evaporates, and therefore the amount of rainfall at a place over a particular period is measured by a rain gauge. So that the surface, they actually collect the water and they percolate the water into the underground layer. So that's what we cannot measure the rainfall from the surface. That's why we use the rain gauge for measuring the amount of rainfall. Next is measurement of rainfall. So rain gauge, a rain gauge consists of a cylinder which has a vessel at the bottom to collect water and a funnel on the top. The circumference of the top of the funnel is equal to that of the cylinder. So you just, this is the rain gauge. Okay, there have a funnel, okay, as a same diameter like the cylinder. So with the help of this instrument we can measure the amount of rainfall, and this is the measuring jar. So the rainfall or rainwater, they actually collect in this jar, and after that we actually poured it into this measuring jar, and by this we can easily measure the amount of rainfall. Precautions while using a rain gauge: the rain gauge should keep 30 centimeter above the ground. It should be protected from animals. So it should be protected from animals when we need to measure, and it should be situated above the ground in 30 centimeter above the ground. Next is sunshine. The amount of sunshine a place receives depends on the season and by the position of the earth in its revolution around the sun. In the meteorological station, sunshine duration is recorded by a sundial. So sundial is the instrument by which we can easily measure the amount of sunshine in a particular place. The sundial is a glass ball placed on a stand with a strip of paper placed behind it, and this is a glass ball, okay, by which we can measure, and the glass ball concentrates the sun rays on the paper strip, which burns when the sun rays are focused on it, and the number of burns on the paper shows the hours of sunshine. So number of burns on the paper shows us the hour of sunshine. And on maps, places having equal sunshine duration are joined as isohills. If we join the equal sunshine places, so we will get a line, imaginary line, which is called as isohills. Okay. Observation of wind speed and direction. Wind is air in motion. Winds are made up of a series of gusts and eddies that can be felt but not seen. Okay, so we cannot see but we can feel the speed of wind. When leaves fall, trees sway and dust particles move, we realize the wind is blowing, and but there is nothing tangible that we can show or measure unless we make use of some conventional instrument to measure wind speed and direction. The speed of wind is recorded in kilometer per hour. Okay, and the factor determine the direction and speed of wind are follows: that pressure, what is the pressure, and rotation of the earth, and friction of or obstacle. These are the factor for the wind speed. Differential heating of the earth produce high pressure and low pressure, and winds are always attract towards low pressure from high pressure regions, and wind blow from high pressure to low pressure depending on the intensity of pressure. An example: wind from subtropical high pressure blow towards equatorial low pressure belt. The earth rotates at different speed at the equator and near the mid latitude. This difference in speed of rotation causes Coriolis force called Ferris law. So the always wind is blowing from one place to another place with maintaining the Ferris law. Okay, or it is regulated, or it is towards bent into the pole with the help of Coriolis force. Okay. And as per this law, wind is the northern hemisphere as are deflected to the right and in the southern hemisphere to the left. And the wind velocity depends on the friction or barrier it faces, and the winds blow with great velocity in the deserts or over the oceans where there is no obstruction. So wind velocity depends on the friction barrier. So these are the indicators. So first one is the pressure. What is the pressure and what is the difference between low pressure and high pressure? This is the another one cause. And the another is rotation of earth. What is the speed of rotation? And the rotation of earth, that in the equatorial region the rotation speed is very high, therefore the wind is blowing very fastly, but in the polar region the rotation speed is very less, that's what the wind also blow in a slow motion. And function of friction and obstacle, that what is the land surface condition, and it is the another factor of the speed of wind. And determining wind direction, so with the help of wind vane we can determine the wind direction, that wind vane and weather clock. And as the wind direction is mostly blocked by trees and by buildings, a wind vane needs to be erected in an exposed position to get the correct picture. And the wind vane is made up of two parts: the part with an arrow or vane mount on the top or pole, which is free to move with the prevailing wind, and the wind catches the tail of the arrow and swings the arrow to the direction from which the wind blows. So with the help of this wind vane, one portion we can measure the direction, and the another part we can with the help of this we can measure the speed of the speed of the wind. So this is the wind vane. And the wind speed, that winds originate due to air blowing from high pressure area to low pressure area, and the wind speed is measured by anemometer. So we can measure the wind direction with the help of wind vane. Okay, and the another instrument like wind vane, this is wind speed instrument, that means the name is the anemometer. With the help of anemometer we can measure the speed. A cup anemometer consists of 3 or 4 metal cups mounted on a pole. So these are the cups. Okay, the 3 or 4 metal cups are mounted on the pole, so that the cup will catch the wind and spin the wheel at a rate proportional to the wind speed. And a dial at the base record the number of times the cup turn in a fixed period, and wind is measured in knots. So with the unit knot we can easily measure the wind speed with the help of anemometer. And always anemometer is fixed with the wind vane. These two are situated in a same position. So by these two instruments we can easily measure the wind direction and wind speed. Next is isotherms and isoheats. Isotherms is what? That a line on a map or chart of the earth's surface connecting point having the same temperature at a given time or the same mean temperature for a given period. So isotherm means where the temperature is same. So if we draw an imaginary line with these points, so we will get one line, it is called as isotherms, equal temperature places. And the isoheats means that an imaginary line drawn on a weather map connecting point that receive equal amount of precipitation. So where the precipitation or rainfall is same, if we draw a line with this place, then we will get one isoheat, which line shows us the equal precipitation places.